Good morning, ladies and gentlemen. Do this now. Doug Pfister throws a .135 kilogram baseball at 41.4 meters per second. How much K does it have? How much work did he do? Extra credit there as well. How fast was it going? Okay, let's do this.
Pause this and give it a shot. While you're saying that, Doug Pfister used to be in physics at Golden Valley High School. You might not know who that person is. Google him.
He was just inducted into our Hall of Fame.
Yeah.
Okay, so the first question is how much kinetic energy do we have? And kinetic energy is 1/2 mv squared, which means 1/2 my mass is point times 135 kilograms, and my velocity is 41.4 meters per second. This is easy. Okay, let's get up.
Squared.
Squared. Don't be like Ms. Moore. Don't forget your squared. Okay, so 0.5 times 0.135 times 41.4 squared, and I get 116. 116
Joules.
joules. Okay. B, how much work did he do?
Where'd that kinetic energy come from?
Well, the kinetic energy came from the work that the force times the displacement of his arm, right?
That's right.
So can't we know that work equals the change in kinetic energy, right? Oh,
Before he threw it, the ball had no kinetic energy.
yeah. So can't we just say that the work is equal to this?
Absolutely yes.
Okay.
What does equal mean anyway?
Yeah. This is easy.
It is.
Okay. Extra credit. Let's do it. He throws a pitch that has 97.3 joules of kinetic energy. I'm gonna go do this in purple. So my work is, my kinetic energy is 97.3 joules. How fast is it going?
I need that equation right there.
This one right here, right?
Yeah.
Okay, we want to figure out how fast it's going because we've got kinetic energy. We want to figure out how fast. We've got the mass up here
How
still.
do you get rid of the 1/2?
Well, in order to get rid of the 1/2, we have to do the opposite of whatever is right here, which is divide. Let's go ahead and multiply by 2 on both sides because those are the rules of math.
1/2. How do you get rid of the mass?
Let's divide. So it's multiplication right now. We can divide. Now we've got v squared left.
We don't want the square of the velocity. By the way, cancel those masses.
Oh, thank you. So let's take the square root of it. Taking the square root of it on both sides is going to cancel out
The squared.
Yeah. Okay.
And that, believe it or not, boys and girls, that's a velocity.
So velocity equals, let's write this over here, equals 2 times the kinetic energy over the mass. Boom. Okay, let's plug this in.
Kinetic
97.3?
3, and the mass is point
I cannot.
135 kilograms. Well, it's early.
Yeah. 97.3 joules, and my mass, what was it? 0.135?
Yeah.
Running out of space over here. Okay, so let's go ahead and do the square root. Can I just write it in here like a sentence? 90. I don't have to put
Yes,
anything.
you can. Just put second square root.
Like this, right? And
Yep.
then divide by, just all straight in a row.
Yep.
135. I think we're good. Okay, so I'm gonna get 37. Let's go at 38.
38 meters per
Dang.
second.
That's fast.
Try hitting that one when it comes at you.
Yikes. Okay, we're done.
Yeah, Doug Pfister was in professional baseball.
Okay, write these bad boys down. We're gonna be using them for the next few questions.
Do you speak algebra? Do you understand what these equations are telling you?
Let's take a look. So these equations communicate ideas to us. So work is the amount of force that you exert on something over a certain distance. Work is also equal to any change in energy that you have there.
Work changes energy.
And work changes the
And
energy.
equal means the same.
And then the kinetic energy is equal to half of the mass in the velocity squared.
Yep. So that's just review, just to make sure you guys remember this mess.
Okay, let's do your practice problem. Miss Moore and her bike have a mass of 68 kilograms. So mass, I'm gonna put Moore plus bike. M plus B is Moore plus bike. 68 kilograms. How much kinetic energy does she have when she rides with a velocity of 6.48 meters per second? Okay, well, I want you to know the kinetic energy.
Yep.
I know the equation for this.
1/2 mv squared.
So 1/2 times my mass is 68 kilograms times my velocity is 6.48 meters per second. 0.5 times 68 times 6.48, and I get oh, I didn't square it.
Oh!
See, Miss Moore? Okay.
Boys and girls are screaming at the monitor here,
I know.
telling you, square it, square it, square
Miss
it.
Moore, don't forget to square it. 68 times 0.48 squared, and that gives me 7.8. 7. Is that number right?
That doesn't sound right to me.
Doesn't sound right to
no,
me.
That's gonna be.
Oh, do you want to know why? I forgot my 6 right there. You see it?
Oh no, I can't see it, but I'll take your word for it.
So 0.5 times 68 times, and I forgot 6.48 squared.
So what?
There we go.
What do you got now?
So now I got 1,428.
That sounds like a more better number. So now see what Miss Moore did. You know, you're sitting there. You always have to be careful about what you're doing. Does your answer make sense? If the answer doesn't make sense, it's time to go back and say, what did I do?
Yeah, because I got 7. I'm like, we've got a big number. I mean, this makes it a little smaller, but we got a big number. It can't be
And you're
small number.
squaring it, yeah.
Yeah, and usually the amount of kinetic energy is, well, kind of a lot. I mean, think about it. I'm riding my bike. I'm putting a lot of work into that, right?
Yeah.
Okay, how much kinetic energy does she? Okay, we're done. that many joules. How much work will her brakes have to do to stop her from that speed?
What does work do?
Well, work changes energy.
That's right. Work changes energy. So
And
if you've got energy, how much energy is it going to have when it's stopped?
okay, well, if it takes me this much to move, it's got to be the same number but opposite to stop.
You're right.
Right.
That's
So
true.
work changes energy. It'll be this number right here, but it's a negative number.
Yep. Because
I'm
it's going to. The
stopping.
final energy is 0 minus the original, so that gives you a negative.
Mm-hmm.
Sweet.
Sweet. Yeah. 0 minus this, and it's 0 because it's the final kinetic energy, which
Yeah.
I'm stopped, right?
Yeah.
Okay, she puts her brakes on and comes to a stop in 4.65 meters. What was the average force required to stop her?
Work. What's work?
So I've got work, I've got distance, and I want us to know force. Well, work is
Force times displacement
displacement.
in the direction of the force.
So I can solve this for force, yeah?
Yeah.
So force equals work over displacement.
And our work is negative 1428. And the displacement is positive 4.65. You don't go backwards when you put the brakes on.
Meters. There we go. Okay, and I'm using this negative number because we're asking how much force it's requiring me to stop, right? Not how much force it's requiring me to go. Negative 1428 divided by 4.6, and I get 6.5.
Yeah.
6.5, and I get negative 307
307
newtons.
newtons.
Negative 307 newtons. Okay.
All right, what's next? This stuff is simple. Oh, it's a Eureka video.
So you're gonna pause this video. You're gonna go to the next slide. The next video, and watch my Eureka video.
All right.